Okay, not a whole lot of C++ today because I was working on a game. Should I have? I'm not sure, but we'll at least get an hour in. It's fine. So, we're passing functions as arguments to other functions, huh? Right? So, well, I don't even want to include anything. We'll just do void test, and then we'll have void, or we'll say void parent, void child. Okay? And so, what if we say that parent accepts a function as an argument? Wouldn't it have to be named? Does it matter what the name is then? Seems like it wouldn't. So the end result is to call parent with child. That doesn't happen yet. Parent doesn't take any arguments. Or it doesn't take arguments, it doesn't have any parameters. But what if we made one and it was a void returning function and it's called x, boom, we call x. Interesting. And then if we made this int a, make it unused, and I call it with child, or wait, hold, we call x with 3. So this guy's expecting a function to be called to it, and it will call it some value, but that doesn't need to be specified in here, which is interesting. What if you said a, and I passed it child with 3? No? Okay, makes sense. Interesting. Okay. What would be a point? What would be the point here? I mean, one is like standard uniform int distribution, and we're passing in the Mersenne twister, which gets called by it. So standard uniform int distribution looks like it has a function that's just the parentheses, and it takes a function that returns some specific type and has no arguments. I guess that's the Mersenne twister. It returns some sort of value that it can use. Maybe an int returning value or an int returning function. Okay. So we can pass a function as an argument to another. And the functions that are passed are called callback functions. So one function calls the one that was passed to it, callback. Oh, like standard sort? Because in standard sort, we're passing in the function that returns the Boolean. So standard sort takes 2 values, passes it. It'll take one and then the next value, sequential, pass it to a function, and see whether it should be sorted or not. It should be flipped. If it returns true, then it will sort. That makes sense. what if we did, well, I get it. This is just a use case. It's fine. It's not that crazy. Okay. In this case, we're saying passing an array. A C style, really? In pointer, a pointer to an array. Okay. If it's not valid, return. So we're not passing it via reference this time. We're not doing a standard array. We're doing a C style. Because, and we're starting at 0 and we're going until below the size -1 because once we compare the second to last value, we're comparing it to the last value. And that means the last value gets sorted when the one before it gets sorted. So we don't use the last value. And it doesn't have an after. Get the smallest index, loop for again, find where the smallest index. If smallest index is greater, this is trash. I'd rather just say if the next one is smaller than our smallest index. I'm not going to look for when our smallest index is greater than something. It's just dumb. And it just doesn't sound right. Then we'll swap them. And instead of if this, we just call if called. Oh, so the point is we could pass this a function, and we can call function, and it will pass in this guy and this guy. See? Yep. Comparison is going to come to should swap. Swap first is greater than second. Now we're doing our check and we're passing. In this case, we're just calling them. Instead, we could add it. In this case, yeah, it's a returning function. It's int, and we need a pointer to it, pass it somewhere. Excuse me. Okay. Yep. So we pass this guy here. Call it comparison. Comparison function is a pointer returning function. In this case, we call comparison function. This is doing the implicit indirection. Right? So we don't have to actually dereference comparison function first, then put this in parentheses. We can just do it.
Do it. Do it.
Oh, that was pretty good.
Do it.
Oh, that's okay. That's like 7, 8 out of 10 maybe. Here, pass that in. Cool. Maybe he's checking to see, hey, is the first less than the second? Return true, so return less 1 less than 2. First one A less than B, B less than C, whatever. We swap it so that we're going greatest to least. Okay. Different functions that we could do. We can sort the same one different ways. Okay. So we have the array. We sort it, print it, sort it different. Caller. Yep. x is even and y is odd. X goes first, no swap needed, so we return there. Or the other way. We want every time is all even odds. Oh, and that's why we call this one evens first. Since we have an array and then we sort first. So we don't care about the numbers. It just so happens in this case that they're actually hold. Oh, we already have ascending elsewhere, so and when we loop through it again, okay, so it's going to go through a swap the even. Then once it goes, it pairs each other, sort and ascend. Interesting. Functionality, gotcha. So we have something that's just waiting on the function. Pass it our function. Does what it needs. Yep. If a function parameter is of a function type, it will convert it to a pointer to meaning that we can write the function, we convert it to a pointer. I'll stick with pointer. I don't have to memorize. Yeah. Oh shit. Alt function. Call it specifically, but so IntelliSense would ask for a third parameter, but if we did it, IntelliSense might say what it to. Yeah, because if function pointer, then it won't default. Say, hey, there isn't pointer to an array or pointer to size. to a standard function and point to a returning function with no arguments. A function pointer, returning no arguments. No parameter rather. Then I can set it instead. Look at goo. Then I can call it like another one. Don't specify. Okay. Specify stuff. Yep. I already saw that. Still do the implicit direction. Type reference for function pointers, meaning auto as well. Yeah. Earlier we saw that it was automatically. Well, we can't do it on argument. Yeah, we can do auto here. Yeah. That one would. Meaning what? Because we can't see the names. So if we had main. Okay. No, that's not what I want. This will work. Okay. We have main. And we have a function. I don't feel like doing maybe unused. Then we'll do cool. But then if we did auto called. Oh, it still does, huh? I don't see anything hidden from using auto. I think that's fine. Oh, the point is here it's hidden. IntelliSense still reveals the details. Function pointers storing functions in an array. Really? Standard function. Okay, let's do standard function. It's in the functional library. Why are we needing it? Because need standard function. Oh, duh. Oh, that's cool. Hold. I thought, what did I fuck up? Did I just not compile again? Maybe this is, no, I had different errors. It was expecting a semi. Okay, I guess not, whatever. Then we could do the same thing here, and we could say a void function. It's called nothing, then it takes an int. Stop. And these guys are great. That's it. These guys are fucking fantastic. It's my favorite channel on YouTube. Ah, Dequidum's there too. Hey. Oh! No. Maybe. Okay. Native syntax to declare function pointers is ugly. Let's fix my speech too. I've been talking terribly recently. Native syntax to declare function pointers, ugly and error prone. Recommend standard function. Places where a function pointer type is used once, a single parameter or return value, standard function can be used directly. Makes sense instead of using alias. Yep. Places where using a function pointer multiple times, makes sense to just use an alias to standard function. Yep. Instead of doing standard function this, or whatever, just make it a standard type. Use it. A basic calculator using function pointers. Function pointers. Ah, it's busting it out. Program that asks the user for 2 integer inputs and the character. What am I doing? What in the heck am I doing? What am I doing? This guy's busting it. Oh, this guy's doing it too. How do we want this? Do we want this procedural or do we want some sort of class? Doing this procedurally? Okay. Give me some full stuff. No. Loop. Go again. All right. Calculate, and I guess we'll prompt here. Well, it's a function, right? Well, all right. So I'm gonna calculate, and then we'll say anything else. That's it. No remainder. what we want is to do this until input is valid. We're going to do some input validation. We need an extra thing here. Okay. So this is, yeah, this is fine. Well, the problem is the continue part here. Handle invalid input and the continue. So in this case, we're going to do okay. So we're going to do fuck. I kept pressing Control C instead. It's my mistake. Trying to see if it would tell me how many lines are selected, but no. The point here is we're getting the thing, and then we're looping through handle invalid input, so extraneous input, and really what I should just do is copy paste. No, I guess not. Boom, boom. Maybe. So then also if use a character. You know, I can't put these in their own thing. I have to repeat myself a little bit here, because otherwise we can't continue in this loop. Okay. I could switch, or we could do a condition. If the character is not this, and not this, and not this, and not this, or if it's not found. So we could have the different types of those. We could say this should be a valid integer, so this should be fine. The character needs to be specific. So we'll do excuse me, we could do a C-style array. Ah, fuck it. Well, I thought there was a find. No? Is it standard vector? Oh. Ah, fuck. It doesn't return, or oh, it's, isn't it if? Hold on. No, it's not find if. What does it return? Does it return null pointer? Or doesn't it return the... What does this return? Iterator? Oh, wait. Don't we check to make sure that it's not in? Checking to see if it is not, or we're saying if it is math operation characters end, there it is. If, continue. Oh, oops, I accidentally put a null statement. It is called. Okay. That's it. All right. Yep. So we're getting it now. Sure. Oh, here we go. Hold on. Right function, separate functions named add, subtract, multiply, and divide. Okay. Type alias. Okay. Isn't it just in? Get arithmetic function takes a character and returns the function. Oh, just have a switch. Oh, and returns the function. Returns an arithmetic function. Get arithmetic function. It takes a character operation. Switch operation. We do a case for each. Sure. What's it called? Remainder? Oh, remainder's some crazy shit. It's in functional. Damn. That's probably why he didn't tell us to do it. Syntax is about to look wild. Hold. Oh, none of this shit is for declared. Awesome. Oh, yeah, I guess it didn't. Looks weird. Okay. takes write a function named get arithmetic function. Takes the character and returns the function. Cool. Modify main to call get arithmetic function and call the return value. Sure, brother. I mean, it basically wants me to remove these. I mean, really what he wants me to do is just this. Aw, now I have to fucking include all this shit. Ay, ay, ay. Oh, wait, not that. Come. Math checks. Okay. And sure, some of those could have been const expression, but it's fine. Yeah, so much for validating input, bucko. You're doing this while it's not this, and this, and this, and it. I mean, sure, I guess. How did I do it? I don't even remember. Oh, the search. That's what I did. This is probably more efficient, honestly, than calling the search. Oh, true, because, or hold on. Yeah, but you have to evaluate all these conditions, though. Isn't it better to do or in this case? We're saying while it is not, hold on, while the operation is not this and not that. Yeah, but we have to check each one of these. Not this and not this and not this and not, well, it's actually both because if we get this, then it's done. Just like or if we get this, it's done. Okay, it could go either way. It doesn't matter. Add, subtract, multiply, divide. No comments. Great, awesome work. Arithmetic function. Arithmetic function. Cool. You switch and then you return. You don't have to return that. You can just return the identifier. At this point, I don't even like returning the fucking address of. Cool. Works for me. Oh, motherfucker. I didn't reference, I didn't evaluate as addition our function result. So, granted, it's not possible to call that function with an invalid character, But just in case, I still should have evaluated the pointer first and stored it first. That's why he probably stored it. Yep, did. He stored it. That way he could evaluate it. Or, yes, you can't do both. We don't want to evaluate. We can't evaluate it as a condition and get it. Sorry. Look at it. That's it for tonight. Not very long, but it's fine.